guys, we're going to go through, I'm going to work through the whole review video. I'm going to start with the inverses and go from there. Most of this review we'll be able to get done in class time, so the class video should have the review video posted. But if it doesn't, I mean, most of it will be there. The most likely thing is that the inverses are not going to be the one that makes it. Now, whenever we find the inverse, the first thing we need to do is switch the x and y. So for 41, we get x is equal to 4 to the y. Now, if it starts in exponential, like this one here, we're going to end up in logarithmic. So we need to change it to logarithmic form, which will tell us that y is equal to log base 4 of x. And that's our answer. The other way to get to that is that we could apply log base 4 to both sides. Now, our log base 4 of x doesn't simplify, it's just log base 4 of x. Now, our log base 4 of 4 to the y, the log base 4 of 4, this part of it simplifies out here, just leaving us with the exponent of y. So we're done since y is by itself. And that's it. If we look at the second one, y equals e to the 3x minus 1. Again, the first thing we're going to do is switch the x and y, telling us x is equal to e to the 3y minus 1. And again, at this point, we're going to change it to logarithmic form. And to do that for this one here, we don't do log. We're going to do natural log. And the reason we do this is because the natural log of e simplifies out, leaving us with the 3y minus 1. And our other side is still the natural log of x. Now, at this point here, we would say we would be finished if y was by itself. So the first thing we'll do is have to add 1, telling us 3y is equal to the natural log of x plus 1. And lastly, to get y by itself, we would divide both sides by 3, telling us y is equal to the natural log of x plus 1 over 3. And yes, we will need the parentheses around the x with the natural log. Well, we do or don't, but we do. It'd be better to have it than not. 43. 43 and 44 are similar. They're a little different than the first. But our first main step still stays the same. We switch x and y. X is equal to the y minus 3. Now, the main difference with this here is that we do need the 2 to the y by itself before we can change it to logarithmic form. So that means we're going to have to add 3. Giving us x plus 3 is equal to 2 to the y. Now that we have it in this form, we can do our log base or our switching. And we're going to pick 2 as our base because the side with y, the base of this here is 2, which tells us that we have on the right-hand side log base 2 of 2 to the y, which is going to simplify to y. And our other side is log base 2 of x plus 3. And since y is by itself, we're done. That's all we have to do with this here. 44. Again, our first main step is going to be the same. We switch x and y. Even though it's e, we really do need to get y by itself, just like we did on the last one. We didn't have to do it on the first few because the term with y, the term that had y in the exponent, was already by itself. Now again, we could do the switching method at this point, or we can just apply the natural log to both of our sides, which would give us the natural log of x minus 5 is equal to the natural log of e to the 4y. Our natural log of e to the 4y is 4y. Our other side is going to be the natural log of x minus 5. And lastly, to get y by itself, we have to divide by 4, telling us y is equal to the natural log of x minus 5 all over 4. Switch x and y, get the y term by itself, and then go from there. Now for this next one, we're starting in logarithmic, 45, 46, and most likely all the way to the end, we're starting in logarithmic form, which means our answer is going to be in exponential form. And the first thing we do, just like the last one, we're going to switch x and y. And again, we're going to get, in this case, get the log by itself. Not so much caring about what's inside, just that this log is by itself. And once we do that, we can do our switching method, which is going to tell us that y minus 1 is equal to 7 to the x. Or our other method is to apply both of them to the base of 7. These will cancel, leaving us with y minus 1. And the other side's x to the 7th. And again, just like all the rest of them, we do need to make sure y is by itself. But we have the minus 1, so we would add 1, telling us that the inverse of log base 7 of x minus 1 is x to the 7th plus 1, or 7 to the x plus 1, this here. Let's look at 46. Again, our first step is to switch x and y. Now luckily for us, the log's already by itself. Now we can again do the switching method, which is going to tell us that 10 to the x is equal to 2y minus 3. Now even though it's not written, the base for this logarithm is understood to be 10. So if we did our other method, we could put both sides to the base of 10. Our 10 log base 10, 10 to the log base 10 would simplify out, leaving us with our 2y minus 3. And again, at this point, we do need to get y by itself. So the first thing I can do is add 3 to both sides, telling me that 2y is equal to 10 to the x plus 3. And then lastly, we'll divide both sides by 2, telling us y is equal to 10 to the x plus 3 all over 2. And that's it. Now we're going to look at some with natural logs. Again, natural logs, we start with the same thing. We switch x and y. Now the natural log is already by itself, which is kind of nice. So we could do our switching method, telling us 3y minus 1 equals e to the x. Really what we're doing is applying the base e to both sides. And our e to the ln will simplify out, leaving us with our 3y minus 1. Now we just need to get y by itself. So the first thing we can do is add 1 to both sides. Which y is equal to, well, e to the x and our plus 1 are not like terms, telling us that we have e to the x plus 1. And lastly, we're going to divide both sides by 3, telling us y is equal to e to the x plus 1 all over 3. And that's it. 48, switch x and y. Now, unlike all the ones we've had so far with natural logs, we actually need to get this natural log by itself because the plus 4 outside the natural log needs to be moved to the other side. Telling us that we have x minus 4 is equal to the natural log of 2y. And again, just like with the previous ones, we can do our switching form, which is going to tell us e to the x minus 4 is equal to 2y. Because we're putting both sides to the base of e. So the whole x minus 4 is going to be in the exponent, and the whole natural log of 2y is in the exponent. Well, e and the ln cancel out, giving us 2y. And the other side is e to the x minus 4. Now, since y is not by itself, we do have to divide both sides by 2, because our 2y divided by 2 is just y. And the other side is our e to the x minus 4 all over 2. 49, it's kind of nice. ln of x equals y. Well, we can switch x and y and get this here. If we did like we did on the last few, we put the base e to both sides. E and ln will cancel, giving us y is equal to e to the x. Y is by itself. We're done. That brings us up to number 50. So we can start off with log base 21 of y equals x. And if we do the base like we've been doing, we're going to put both to the base of 21. Because 21 to the log base 21. Those will simplify out, telling us y is equal to 21 to the x. Y is by itself, and we're actually finished with that there. And that's all of our inverses. If you do have other questions, please ask. 1 through 5. Evaluate each of the expressions for x equals -2 and x is equal to 3. So we're doing these here. We can do these one at a time. So the first one is 16 to the x plus 5. I would use the 30xs on this because we can say 16 to the, so our x for the first one is -2 plus 5. Enter. 4096. And we're also doing 16 to the 3 plus 5. And we get this big number here. And we need both. So our first answer was 4096. And that was for our 16 to the -2 plus 5. And we also did 16 to the 3 plus 5, which is 42949679296. And since neither one of these had a decimal, there was no reason for us to round it. If we look at number 2, I'm going to type it in exactly as it says. 7 times our 2 to the -2 minus, I need the plus, minus 3. -5/4. -1.25 and -5/4. Either one, we didn't have to round because it didn't go 3 decimal places. Number 7 times 2 to the 3rd minus 3. Calculator, 7 times 2 to the 3rd. Again, we could do parentheses around the 3. Sometimes that's helpful. Sometimes it doesn't make a difference. But here, 53. Those are our 2 answers. Number 3, 2 to the 5 times -2 minus 2 to the -2. Again, I can grab the calculator. 2 to the 5 -2. Make sure to get out of the exponent because that can make a difference, to make sure we typed it in correctly. -0.249. Since we did have a decimal, we're going to round to 3 places. If you do get a big decimal, make sure to round to the 3rd place. And then we're going to do the same thing with 3. $32,760. And those are our 2 answers. Number 4, 6 to the -x minus 1. So we'd have 6 to the -2 minus 1. 6 to the -2 minus 1 is 6. We could also have 6 to the -3 minus 1. 6 to the -3 minus 1. 0.00077. If you're not sure where to round, or if you're rounding correctly, give me more spaces. I won't ever count off for giving me too much. So if you're not sure, just give me a few more spots. And the last one, 1/5. So we'd say 1/5. to the negative 2 plus 2. And you can put parentheses around the value you're plugging in for x, or where x should be. So 1/5 to negative 2 plus 2 is 1. And then we'd also have 1/5 to the 3 plus 2. Point 0032. How many zeros? 3. And that's it. I wanted these 6 through 11 to be on the test, but they're not. And you can look at the answer key, but I'm not going to worry about those there. Rewrite each equation in exponential form. So we're going from our log base b of y equals x if and only if b to the x is equal to y. Or the natural log of y equals x if and only if e to the x, because our base with natural logs is e, is equal to y. So we're using one of these two here. Now for our first one, if we use this switching method, it'll tell us 9 to the 4th is equal to 6,561. The way we did, especially with our inverses, is that we could use the base of 9, because our log 9 to log base 9 will cancel, leaving us with our 6,561, and our other side would be 9 to the 4th. And that's it. Our next one would be 5 to the 7th is equal to 78,125. And that's just using our switching method. The other method is putting both sides of the base of 5. And the reason we're choosing 5 is because the base for the logarithm is 5. Because 5 to the log base 5 would cancel out, leaving us with the 78,125. And the other side is 5 to the 7th. 14. Well, with our switching method, we had 1/7 to the negative 4 is equal to 2,401. We're just putting both sides to the base of 1/7 because those will cancel. We're picking 1/7 because the base of the logarithm is 1/7. This is this here and this here. And our last one would be 15 to the 1st is equal to 15. Here we're using our e, and this here would be e to the 7th is equal to x. And if we did just like the inverses, we're applying a base e to both sides. E to the ln will cancel, giving us our x, and our other side is e to the 7th. Same thing is true with 17. Apply base e, e and the ln will cancel. Minus 6 is equal to e to the y. E to the y equals x. We can have it either way. 18. E to both sides, e and the ln will cancel, leaving us with e to the y is equal to 71. Now with equals, it doesn't matter if we flip it. Inequalities we'll have to be a little careful with, but we can talk about that when we get to solving. And with 19, e to the 9th. Flipping it either way doesn't matter. We get to the same answer. Now we're going the other direction. Still using the same formula. And if we did the switching method for this here, it'll tell us that log base 3 of 81 equals 4. And really what we're doing is just applying log base 3 to both sides. And the reason we chose 3 is because here the base of what we started with is 3. And our log base 3 of 3 simplifies out, leaving us with just the exponent of 4. And the other side is log base 3 of 81. We can do a similar thing here, but since our exponent is attached to the 1/5, we'd say log base 1/5 of our other side, 1 over 125, is equal to 3. Because what we're doing is log base 1/5 of 1/5 to the 3rd is equal to log base 1/5 of 1 over 125. Log base 1/5 of 1 over 125 stays. Our log base 1/5 of 1/5 of the third just becomes 3. Here, our base is 125, so we'd say log base 125 of the other side, 25 is equal to 2/3. And that's it. Here are the answers. 23, now we're doing essentially the same thing, but this time we're using ln, because e, whenever the base is e, we use the natural log. And if we did the switch for this here, it'd say ln of x equals 4. Because when we apply the natural log to both sides, ln of x does not simplify, it says ln of x. But our ln of e does simplify out, leaving us with the exponent of 4. Now our next one, if we did the switching method, would be ln of 27 equals y. Because when we apply ln to both sides, ln of 27 doesn't reduce, stays ln of 27. Our ln of e does, leaving us with our y. And last one, we can just switch it or apply ln to both sides, and we just get ln of y equals x. Now with these here, we're just plugging them in. For a log base, if the base is something other than 10, we can type those in the calculator. And we get that by doing math, scrolling up or down to log base. And our first one, let's flip to the right page, is log base 5 of 1 over 125 is -3. And we can do the next one. I'm not going to flip back and forth just to save a little bit of time. We can go math, log base 9 of 2187, 3.5. Math, log base 10 of 0.1234, 4 zeros and a 1, we get -5. Now the natural log is nice because we can just use the natural log button, because the next one's the natural log of 27. So I'm going to flip back over this here. So we did go through these first through. The calculator did give us the answer. It was -3. (3.5) -5. Now, when we typed the last one in, we got a long decimal, so we're going to round to 3 places. So we just take 3 places out. If you're not comfortable or not sure you got the right rounding, especially for these here, give me more digits. There's nothing wrong with giving me more digits. And natural log, we can do in either one, because the 30xs for the next one, we could say the natural log of 2 over 7 is -1.2527. Since we're rounding to 3 digits, the second 2 becomes a 3. And the last one, natural log of 4 to the 6. And all of these here, any of these here, evaluating when we're given logarithms, type them in. Type them in exactly as you see it written. Don't change a thing to it, just rewrite it, parentheses and all. Type it in exactly as you see it. Problem 25, 32 through 35. Expand, quotient, product, power. This is the order in which we expand our division, our multiplication, and then our exponents. And we do it in that order. Now, if we look at 32, there is no quotient, there is no division so we don't have to do step 1. We move to our product. And our product states whenever we have multiple things being multiplied inside a logarithm, we can rewrite it as separate logarithms with what is inside being added together. Is our product. Our power property states that we can take the exponent of what's inside our log and move it to the front. Now we can only do this with a single term. That's why we had to do product first. Now our log of 6 is still going to stay log of 6. But our log of x to the third becomes 3 times log of x. Plus, we move the 2 out front, giving us 2 log of y. And that's it. Some programs, some calculations would expand or take log of 6 a little further, but we're not going to do that. We're not going to break it down any further than that there. And that's it. 33. Now this one does have a division. It does have a quotient, and we start with it. And it'd be log of the top, numerator, minus log of the denominator, y cubed z squared. Now both of these denominator terms, when we get it all the way factored out, the sign in front of each of their logs, respectively, will be a minus sign. Now our first part, log of 7x squared, we can break it apart just like we did the last one. It would be log of 7 plus log of x squared. Minus. We can do the same thing here. And we'd have log of y squared. And we'd have log of, not y squared, y cubed and z squared. Y cubed and z squared. Now, since both of them were in the denominator, their sign, the sign in front of both of them, should be minus and minus. We could think of it as this whole thing in parentheses being added, and then we would distribute the negative back through. However you want to look at this, it comes out to the same thing, that those two terms, the terms in the bottom, their logs will have a minus sign in front. And the last thing we're going to do is power. So we're going to move the 2 out front. Now log of 7 is going to stay log of 7. But our log of x squared becomes plus 2 log of x. Minus, the sign's still going to stay there. We move the 3 out front, giving us minus 3 log of y. Same with z. We move the 2 out front, giving us minus 2 log of z. And that's our answer. 34. Again, we have a quotient. We'll start with it. Now, even though it's natural logs, we do the exact same process. Natural log of the top minus the natural log of the bottom. Now, our first one, our product, is going to become natural log of 7 plus the natural log of x to the third. And since both the 7 and x to the third were in the top of the fraction, the sign in front of both of their logarithms stays plus. Now we can do a similar thing with our 16 and y squared. You get ln of 16, ln of y squared. But because these are both in the bottom of the fraction, the sign in front of both of them is going to be minus. Now lastly, we can deal with our exponents, which would give us ln of 7 plus 3 ln of x minus ln of 16 and minus 2 ln of y, as we've seen in the previous ones. 35. We have no quotient, but we do have product, so we can break it apart into its multiple parts. So ln of 8 plus ln of x to the third plus ln of y squared plus ln of z to the fourth. Since we have that finished, we can do our product, giving us plus 3 ln of x, plus move the 2 ln of y, plus, our last one we'd have 4 ln of z. And that's it. That's all we have to do on this one here. Condensing, we work in kind of reverse order. First one we're going to do is powers, and if there are negatives, take the negative with the exponent, or just take the negative 1 as the exponent. Product, and then simplify where needed. So for 36, the first thing we're going to do is take the exponents and put them back. For our 6 log of x, we get log of x to the 6. Plus, for our 5 log of y, we get log of y to the 5th. And for our negative 4 log of 3, we get plus log of, parentheses is not necessary, log of 3 to the negative 4. We'll have to simplify that negative 4 later, but it makes it a little bit easier to work with. Now, we have 3 things being added, 3 logs being added. Well, we can rewrite it as a single log with what's inside being multiplied together. Now at this point here, we do need to do some simplifying, and the main reason we need to do that is because our 3 has a negative exponent. To make that exponent positive, we move it from the top of the fraction to the bottom. Our x to the 6, y to the 5th stay on top because their exponents are positive. Now we can simplify a little bit, and that's our 3 to the 4th power. If we have a number to an exponent, we're going to check and make sure it simplifies. If it does simplify nicely, we will replace it, telling us that this one here condenses log of x to the 6, y to the 5th over 81. We'll look at 37. 37, again, we start with exponents. 39, telling us that we have log base 4 of x to the 3rd, plus log base 4 of y to the 9th. Since we didn't have any subtractions, negatives in front of either of these, we just take the positive exponent. Now since we have 2 logs being added together, we can write it as a single log with what's inside both of them being multiplied. Now as we look at this here, since neither exponent is negative, no numbers to simplify, that is it. Log base 4 of x to the 3rd, y to the 9th. We can look at 38 next. 38, the first thing we're going to do is our exponents. We're going to move the 6 up, and even though it's natural logs, they still work the exact same way. And with our negative 4, we're going to take the negative 4 in as an exponent. Because when we do that, we end up with 2 natural logs being added. And whenever we have more than one log or natural log being added, we can rewrite it as a single logarithm with what's inside being multiplied. Now, unfortunately, well, not really unfortunately, but unlike the last one, we do have a number with a negative, or term with a negative exponent. So to make that exponent positive, we move it from the top of the fraction to the bottom. Now, what is nice for us is that 2 to the 4th will simplify nicely. 2 to the 4th power is 16, telling us that this is the natural log of x over 16. And that's it. 39. Again, we start with our powers. Doesn't matter if it's a variable. Here, 5 ln of x becomes the natural log of x to the 5th. Move that 5 back up into an exponent. The next one, we're going to take that negative y as an exponent. So it's going to become plus the natural log of 27 to the negative y. Nothing's changing. Nothing's going to be different from the previous ones. Since we have 2 logs being added together, we can rewrite it as a single log with what's inside being multiplied. Now, since we do have a negative exponent, to make it positive, we move it from the top of the fraction to the bottom, which turns into 27 to the y on bottom. The top is still x to the 5th, telling us that this is the natural log of x to the 5th over y, or 27 to the y. Last problem is this one here. And again, with this here, we're going to start off with our exponent property, which is going to tell us that this is log of 2 to the 3rd plus log of x to the 4th plus log of y to the negative 3rd plus log of z to the negative 4th. Since we have 2 or more logs being added together, we can write it as a single log with what's inside being multiplied. Now, since this is just one number and three variables, we can just write them next to each other. We don't have to put the multiplication sign in between it. We can if we want to, don't have to. Now, this time we do have two terms with negative exponents, and to make each one of those positive, we would move it from the top of the fraction to the bottom. And the 2 to the third x to the fourth would stay on top. Now our 2 to the third does simplify nicely. It simplifies to 8. Everything else stays the same. But that there would be our final answer. And that's the entire review sheet. If you have additional questions, please ask.